What is the historical significance of the quadratic discriminant? Imagine trying to figure out if a mystery box has 1, 2, or no hidden treasures inside without opening it. That's similar to what the quadratic discriminant does for equations. It helps mathematicians understand the nature of the roots of a quadratic equation just by looking at its coefficients. The quadratic discriminant is the expression B2 for AC, where a, b, and c are numbers in the quadratic equation. X2 plus bx plus c is equal to 0. This simple formula has a long history that shows how algebra evolved over thousands of years. Ancient civilizations like the Babylonians around 1800 BC used geometric methods to solve quadratic problems. They didn't have symbols or equations like we do now, but they understood how to find solutions by completing the square. Their work always gave positive answers because they dealt with lengths and areas, not negative numbers. Later, Greek mathematicians like Euclid looked at quadratics through geometric shapes, but they still didn't use algebraic symbols. The real shift came with Indian mathematicians such as Brahmagupta in the 7th century. They started to use symbols and accepted negative numbers, which made solving equations more flexible. During the Islamic Golden Age, Al-Khwarizmi in the 9th century classified quadratic equations systematically, but he didn't have a way to tell the nature of roots without solving them. The concept of the discriminant as a specific expression that reveals whether roots are real or complex became clearer during the European Renaissance. Mathematicians began to write equations symbolically and understand how coefficients relate to roots. By the 19th century, mathematicians like James Joseph Sylvester extended the idea of discriminants beyond quadratics to higher-degree polynomials. They used it to determine the number and type of roots for more complicated equations. Understanding the quadratic discriminant is important because it quickly tells us if roots are real or imaginary, if they are different or the same, and how the parabola opens. It made algebra more straightforward and less about trial and error. This idea helped shift algebra from geometric sketches to symbolic problem solving, making it easier for students and mathematicians to analyze quadratic functions. Today, the discriminant remains a key tool in algebra, connecting the coefficients of an equation to the shape and roots of its graph.